Reduction to linear form, example 2. Consider the following data collected from an experiment. So here we have some data, some values of x and corresponding values of y. We know that this data follows a law of the form y equals ax squared plus b. This is not a straight line. In fact, the equation is quadratic, so if we plot it, it's going to produce a parabola. The values of a and b might be difficult to find from a parabola. So could we linearize and draw a straight line graph? It turns out that's quite straightforward to do. So all we need to do is let big Y be the same as y, and big X be equal to x squared. Then the equation becomes y equals ax plus b, which is a straight line with gradient a and y-intercept b. So what we do is we plot y against x squared. So we need a new table. And what we have is the values of big X and the values of y. And remember, big X is little x squared. So instead of 2, 4, 5, 6, 7, 8, we've got 4, 16, 25, 36, 49, 64. But notice that big Y was equal to y. So we still have exactly the same values for y. So what do we need to do? We need to plot this. So we're going to plot the values. Remember, y equals ax squared plus b is our actual rule. And then we want to find the values of a and b. We're going to find those by plotting all of these points. There's 25, 2.2, and 36, negative 0.1. And, oh, that's not quite in the right place, is it? Never mind, you get the idea. And then we'll draw a straight line through. And so what can we see? Well, the intercept there, and then take 2 convenient points for the gradient. It looks like that's 60 across and 11.1 down. And so what do we have? Well, b, I'm going to say, is 6.5. And a is negative 11.1. Remember, this goes down, divided by 60. So a is negative 0.185. Now, obviously, when you're doing this, you might get a slightly different answer to the person next to you. But it doesn't matter. It should only be slightly different. So the law is going to be, just put the values of a and b back into our equation. Y is negative 0.185x squared plus 6.5.